Okay, so Assalamualaikum and salam sejahtera. Okay, for today's video, I will teach you our last subtopic, which is 1.3, inverse functions. Okay, so let's go through. Okay, for this subtopic, we only have four learning objective, which is the first one is how to describe the inverse function. The second one, what is the properties of inverse function? The third one, how to verify inverse function. And then the last one, how to determine the inverse function. Okay, now so we go through lesson number 4. Lesson first, learning objective first, the first one. Okay, now describe the inverse function. Okay, so the first thing that you need to know, inverse function, it's written as function, inverse function of x, inverse function of x, inverse function of x. This is the power of -1 here. Inverse function of x, we call it as inverse function f of x, inverse function f of x. Okay, now this is a tree diagram, right? Okay, this is the normal tree diagram you see, which is function f of x equal to y, which is this is the normal tree diagram, arrow diagram. Function f of x is equal to y, right? This is the normal thing you see. Okay, now how about inverse? Inverse is like this. This is the inverse. Okay, the inverse function. Okay, so how you want to write? Okay, the inverse function is inverse function f of y equal to x. Inverse function f of y equal to x. This is how the different. Look at this one. This is what the inverse happen. X will become this one. It's the normal one. X is the object, and then y is the image. And then for the inverse, y will become the object, and then x will become the image, like that. Okay, now look at example 13. Okay, for example 13. Okay, look at example 13. Okay. Okay, in the arrow diagram on the right, the function f map x to y. Function f map x to y. This is the normal function that you already learned. Okay, now what happened when the question asks you to determine inverse function f of 1/4? So 1/4 will become the object for the inverse function. So 1/4, this is the object, and then the image is 2. So the image is 2, like that. Okay, now determine for B, determine inverse function f of 5. So you know that 5 for the inverse, it will become the object, and then this one as the object, so the image will be 3. So 3 equal to 3, just like that. Okay, that's it. Alright, so okay, done for how to describe the inverse. Okay, now let's proceed lesson number 2 for the subtopic 1.3. Okay, lesson number 2 is what is the properties of the inverse function. So this is the main important properties of the inverse function, which is it is one-to-one function. So remember, for inverse function, it is one-to-one function. Okay, now look at lesson number 3, how to verify inverse function. So how you want to verify? Verify means you need to prove that the function given is inverse or not. So the first one, if the function is the composite function, okay, so if the composite function, which is fg, function of fgx, composite function fgx equal to gfx, equal, so we can consider this one as the inverse. So it means that function of f is the inverse of function of f is the inverse of function of g, or otherwise lah, which is function of g is the inverse of function of f. So it can be either one as long as if the composite function fgx equal to gfx. Okay, so number 2, you want to verify for if you want to verify the inverse function for number 2, you need to use horizontal line test. This one, if it is given to you a graph. Okay, before this, you want to verify whether that one is the function or not, you need to apply a vertical line test, right? But if you want to but for this one, if you want to verify inverse function for the given graph, you need to use horizontal line test. Horizontal and melintang, like this. Okay, now look at example 15. Okay, example 15. Okay, look at this one. Okay, remember the properties of the inverse function is one-to-one function, right? So if the horizontal line test like this, if the horizontal line test was applied on the graph, if the point touch at one point, if the graph touch the horizontal line test at one point, so we consider that one as the inverse function. But if the horizontal line test is applied, then the graph intersect, or if the graph intersect with the horizontal line test more than one point, so we consider this one as not inverse function. Because of what? Because we know that the properties of the inverse function is one-to-one, right? So it must have one object, an image. It cannot be more than that. So but if this one, it will touch it intersect with 2 points, so it means that it is not inverse function. Remember this one. Okay, now look at this one, example 15. Okay, the question asks you to determine whether each of the following function f has an inverse or not. Give your reason. Give reason for your answer. Okay, this is the arrow diagram. So from this one, you need to know that the properties of the inverse function is one-to-one. So look at this arrow diagram. Is it one-to-one function or not? So A to 4, 1-to-1, B to 2, 1-to-1, C to 9. So this is considered as the function is the one-to-one function. So automatically we know this is the inverse function. It means that the function has an inverse function. Okay, now look at B. B, the question give you in the forms of graph, right? So you need to apply horizontal line test. So you need to apply at any point. So if you apply horizontal line test here, then it will touch at only one point. So we automatically know that this is the function has inverse function. Okay, now look at C. Okay, it is also in the forms of graph, right? So automatically you just apply the horizontal line test. So horizontal line test, if you apply it like this, then there is 2 points here. The graph intersect at 2 points on the horizontal line test. So we can consider this function as not inverse function, or function f has no inverse function. Okay, just like that. It's very simple actually. Okay, now look at example 16. Look at example 16. Okay, example 16, the question asks you to verify that the function fx equal to 3 minus 2x has an inverse function gx is equal to 3 minus x over 2. So the question gives you two functions, which is function f and function g. So you need to apply the composite function lah, which is composite function. If f gx equal to g fx, then the composite function have inverse function. Okay, now look at example 16. Example 16, we need to verify, right? So this one given two functions, which is function f and function g. So we need to do composite function. Okay, remember fgx is equal to gfx. If fgx equal to gfx, then we can consider the function f and g is the inverse, has an inverse function. Okay, now the first thing that you need to do is you need to apply for fgx first. Find this one first. Okay, fgx. So fgx, what is gx? Gx is 3 minus x over 2. Okay, now function f, 3 minus 2, this one the whole thing is x, so 3 minus x over 2. Okay, now we can cut down this one, and then 3 minus negative, okay, 3 minus x, okay, 3 negative 3 positive x. So we know the answer is x for this side, for this one this is x. Okay, now another one, gfx. Okay, another one, gfx. Okay, now find this one. Okay, gfx, fx is 3 minus 2x. Okay, now so now g, the function of g is 3 minus x, the whole thing here, so copy back to x over with 2. Okay, now 3 minus 3, negative positive 2x. Okay, divide by 2. Okay, this one cut. Okay, now okay, so cut. Now we know that this one, we can conclude that fgx is equal to gfx. So we can consider the function of f. The function of f is the inverse of function of gx, which means that it is inverse to each other. Okay, so we proceed with our last lesson, which is how to determine the inverse function. Okay, if you want to determine the inverse function, okay, you need 3 steps. Okay, the first one, change function. Okay, this is the normal thing that you see, right? Function f of x is equal to y, where x is the object and then y is the image, and then you need to change it into function f of y is equal to x, which is y will be changed into the object and then x will be the image. Okay, now the second one, you need to write x is equal to inverse function f of y. You need to make it this one, and then the third one, you need to substitute variable y with x. Okay, how you want to apply these three steps? Then we will proceed with the example. Okay, look at A. Given that f of x is equal to 5x plus 2, then the question asks you to find the inverse function f of x. Okay, how you want to do it? Okay, do it like this. Okay, fx, we know fx is equal to 5x plus 2. Okay, and then if you want to change the function, you need to let y is equal to 5x plus 2, and then you need to make it x as the subject. Because of y x as the subject, because we want to make it the y as the object. So now, okay, y minus 2 equal to 5x. Okay, why I didn't move 5x into the left side? Because this is already in the positive form, so let it be on the right hand side. Okay, and then 5, we bring it to the left, so y minus 2 over 5 equal to x. Okay, now we done for this one, which is we already make it in the forms of this one, right? Okay, now, okay, we already make it in the forms of this one. Okay, now the second one, you need to make it x as the, since x is equal to f negative 1, sorry, tak ada ni. Sekejap. Okay, negative 1. Okay, okay, now x, this one, apply the second step, which is since x is equal to inverse function f of x. Okay, so after that, okay, you need to do like this. Okay, This one not, sorry, this one y, not x. This one y, not x, sorry. F inverse. So we know that this one, f inverse function f of y is equal to x, this one, y minus 2 over 5. Okay, now, so after we apply this one, then we apply the last step, which is substitute variable y with x. So f negative 1 x is equal to, okay, tak muat so is equal to x minus 2 over 5. This is the answer. Okay. Okay, now look at the next example. Okay, look at the next example, which is B. Okay, for B, given that fx is equal to x plus 9 over x minus 8, the question asks you to find the inverse, right? So fx equal to x plus 9 over x minus 8. X, sekejap marker. Okay, tak apalah, it's okay, just use red pen je lah. Okay, now this one, and then we let y equal to x plus 9 over x minus 8. Okay, this one, all this, bring it to the left, so darab lah. So xy minus 8y equal to x plus 9. Okay, remember, we want to let y because we want to make it x as the subject. So just collect all the unknown x to the one side. So I will put the x here to the left side lah. So xy, this one positive x, bawa ke sebelah jadi negative x. This one I will bring it to the right. So 9 negative 8y, so positive 8y. Okay, now this one, just x as the subject, right? So factorize this one. So x y minus 1, 9 plus 8y, and then y minus 1, you bring it to the right side. So x is equal to 9 plus 8y over y minus 1. Alright, so you done already for the first step, which is for the first step here. Okay, now look, we do for the second step. Okay, for the second step, since x is in the forms of this one, okay, now, okay, so this one, we just f negative 1 y equal to, okay, x, this one can the whole thing here. So 9 plus 8y over y minus 1. And then we substitute the value of y to x. So x is equal to 9 plus 8x over x minus 1. So done already. Okay, just like that.